All right, good morning, guys. Let's see if I can work the smartboard and the recording a little bit better this time, even though I still don't know how to make that thing go away when I pick up the line. So today we're going to talk about an ellipse. And an ellipse is a set of points in a plane that creates an oval shape. And that the sum of the distances from any point on the curve to two fixed points, which are called your foci, because there's two of them, is a constant, okay? So basically, an ellipse is basically a circle that's either been squished horizontally or vertically. Okay, so think about how if we start with a circle and then squish it and it'll become an ellipse. All right, so the horizontal equation is very similar to your circle equation, okay? The only difference, because if you think about just the top part here, that's basically your circle equation. The difference is that now we have a squared and b squared that's going to, we divide into, which either spreads it out or makes it skinny. So the horizontal clip is short and fat, okay? And your vertical is, the difference is just your a squared and b squared is switched, and that makes it tall and skinny. Okay. All right, so each type of ellipse has these main parts, okay? The point in the middle is called your center, just like a circle, and uses the same coordinates of HV, just like your circle. The major axis is the line that runs through the center of the ellipse on your major axis on the long way, and that is what we use for A. I wish I could make this pin thing go away, but I don't know how to do that. Let's just drag it down. All right, sorry, I digressed again. So the endpoints of your major axis that are on the ellipse are called your vertices, okay? And your horizontal has the major axis as coming first, okay? So our major axis is going to run here, and the endpoints are your vertices there and there. The minor axis, because it's smaller, is perpendicular to your major, and it runs through the center the short way. So this is going to be my minor because it's shorter than the major, okay? It's used with B. So B is your distance from the minor, on the minor, from the endpoint to the center, and the endpoints are called your covertices. Okay. And then your foci are your 2 points that dictate how fat or how skinny the ellipse is. They're always on the major axis. So like I have the major axis here. There's my vertices. This foci, they're the same distance on each side from the vertice. And depending on where your foci is, that's what makes it big and small. They're found by this equation of a squared minus b squared equals foci squared. So basically think of it as the distance from the major, or the distance on the major from the vertice to the center, okay, minus the distance on the minor, okay, because that's your A, that's your B, and that is equal to your foci distance. And if you kind of think about it, what ends up happening is you're talking about this distance here, and if you subtract this distance here, because we're kind of making a right triangle, and it backs into using the Pythagorean theorem. All right, so back to some equations for you, okay? If you're doing a horizontal ellipse, and remember, that one is the short and fat. Here's your equation. Your center, both, whether it's vertical or horizontal, are the same. Your vertices are from your center plus A, that represents your value. Your covertices are your V center to the B. The length of the major axis is 2A, your minor is 2B, and your foci formula is the F squared minus A squared. Notice when you're doing a vertical, since B squared and A squared flip-flop, so do your vertices and covertices formula. Okay, so let's identify or find the equation from the graph, okay? So we want to find, we're looking for the equation, okay? So let's figure out what the major axis is. So which distance is going to be longer between the two? So to find, I got vertices here and here, and then I have a vertice here and a vertice here. So let's just, because I'm on the graph, I can just count the distance. So I got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So I have 10 distance across on that one. And then from 4, so I got 1, 2, 3, 4, 5, 6, 7, a distance of 8 on that one. Okay, so that means that my major axis is going to be actually on the x-axis, and so that is going to give me a horizontal, and so it looks shorter and fatter. So that means my equation is going to be x minus h squared. A is going to be first. Y minus v squared. B second, and equal to 1. Okay, so let's first find the center using the midpoint formula. Now remember, I had a distance of 10 here and a distance of 8. I can actually draw the axes, and the point of intersection is going to give me my center. I can also use the midpoint formula, taking my ordered pair of -2, 0, and 8, 0. And this one's going to be 3, -4, and 3, +4. Whoops. I don't know why I just wrote like that. Okay. But I also can just draw the axes, and that gives me a center at 3, 0. Okay, so that means that I can fill in part of my equation. So x minus 3 squared, y minus 0 squared equals 1. And I still need to find my a and my b. Okay, well, a is just the distance from the center to the vertice on the major. Okay, well, since this is my major, the distance I can count. 1, 2, 3, 4, 5. So a is equal to 5. 5 squared gives me 25. And now find b is the distance from the center to actually the covertice, because it's on the minor. And so if I count 1, 2, 3, 4, b is 4. And so 4 squared gives me 16. And there's, well, actually, let's simplify this. So I have x minus 3 squared over 25 plus y squared over 16 is equal to 1. And there's my equation. Okay, this time we're actually going to find the equation and then graph it. So the first thing we need to do is we need to plot what points we know. Oh, hey, it's in the first period. You guys aren't here. We got to plot the known points. Okay, so I have vertices at 2, -8. So I'm going to come down here and plot that. I have a vertice at 2, 2. Okay, and since they're vertices, that means that's my major. Okay, and so there's going to be my major axis. I also know that I have a focus at 2, 1. So if I go over 2 and up 1, there's my first focus. So since I have a distance of 1 there, that's going to be my second focus. Okay, so my major axis shows me that that's going to be a vertical equation. And so the form that I'm working with is x minus h squared over b squared, because vertical b comes first, and y minus b squared over a squared equals 1. Okay, so let's figure out now, how do I find the center and all the points that I need? Well, the first one, if we find the center, I need HK. Well, that's going to be the middle of the major. So if I count down, I got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. That means that 10 divided by 2 is going to give me a distance of 5. And since that then gives me my B. So 1, 2, 3, 4, 5. There's my center. So my center is going to be at the point of over 2 and down 1, 2, 3. Okay. Now, if I think about what I know so far, I know my center, and I know my B, but I need the A. I don't know how far out I'm going to go this way. So what I can do is use the focal equation, because remember, focal is equal to A squared minus B squared. Well, I know the focal distance, and I know my A distance, so if I plug and chug, I can find B. So 1 squared, because my focal distance is 1, is equal to A squared, which I found, oh, wait a minute, I'm sorry. My A equals 5, sorry about that. B comes first, but A is always the variable for the major. Need more coffee. Okay, is equal to 5 squared minus B squared. All right, so 1 is equal to 25 minus B squared. So negative 24 is equal to negative b squared. So that makes b equal to the square root of 24, which is approximately 4.89. Okay, well now that I know what b is, I can put it into the equation. And so my center was at 2, negative 3, so x minus 2 squared, y plus 3 squared over b squared. Well, b is square root of 24, so b is going to be 24. A was 5, so a squared is going to be 25, and that's all equal to 1. So there's my equation. Whoops, let's move this up so I can actually graph it now, because that's my next step. Okay, so if b is approximately 4.89, that means that from the center, I'm going to go 1, 2, 3, 4, about right here, and 1, 2, 3, 4, about right here, which then, whoops, if I could get through the point, let's me graph a tall and skinny ellipse. All right, easy peasy, lemon squeezy. Have a good one, guys, and I will see you soon.